Fashion Tech Alliance involves higher educational institutions, small, medium and big enterprises and the research center. This project has been co-founded by the Erasmus Plus program of the European Union and is aimed to facilitate knowledge exchange between partners and to design and pilot learning experiences to engage students in a fashion tech residency program, embedding young talents in the company's innovation activities. A central objective of the project is to design multidisciplinary, interdisciplinary and intersectoral learning activities involving international students from 5 European universities. The contents of the lectures have been specifically created to match the needs of fashion tech learning. They have become open educational resources to allow future engagement between a European-wide fashion and textile HEI community and are available under Creative Commons Sharealike 4.0 with the aim of a wide and free distribution, access, use and reuse. Ready to learn more about fashion tech? Enjoy the lecture.
When it was proposed to us to make these lectures, we have immediately start to understand what we want to do, to propose to you. So we have tried to simplify to some procedure that we usually use in digitalizing and in using digital services and digital tools in our projects. And we are thought about two types of domains. The 2D domains, mainly materials. The 3D domains, it means mainly the product. Here with me, there is also my colleague that is Claudio Pucci, that is a senior design. My background is in aerospace engineering. I'm the R&D manager of Grado Zero Innovation. These are some of the products projects that we have made in several years of experience, more than 20. So we span from automotive to yachting, smart wearables, and so on. We are a group of 3 SME. In this project, it is involved at Grado Zero Innovation. That is one of the last one. We have also an electronic shop of sustainable material. The name is Life Materials, in which we have exported for the B2B some of our of the materials that we have developed in several years of experience. Our main focus is R&D on materials, but we also make product design, prototyping, manufacturing. We have an important department for the all the additive technology. Our focus is that to transform materials and technology into innovation. Going to the lectures. So what you will see. You will have a lecture presentation. We will mainly speak about digitalizing materials. We will see the difference between natural, artificial, and native digital materials. We will see how it is possible to map and texturing the material in a way that you can use in professional rendering. The second part, that is the 3D part, is related to presenting the garment as a potential interface. We have worked a lot in terms of smart wearable. We will start showing one of our prototype, and we will show how it is possible from the biometric acquisition to go through the polygonal modeling, meshing, and obtaining the model, the digital model of potential interfaces that you can produce by additive production. It means 3D printing. When we approach to materials, we approach to materials in a way that we have a sample of a material. When we speak about the sample of material, it means we have the physical material and we have also all the characteristics and properties of the material. This means that sample is always accompanied by a technical data sheet of the material. We don't need to detach the aesthetic or optical parts of the material by the physical part of the material. This is important, especially when we are going to transfer this material into a digital domain. After we are simply set up a very simple studio set, so photo set, in which you can acquire by yourself, you can do also in your home, acquire by yourself the digital pictures of a material. We have used this type of equipment. What you need is a camera, specific lens, lighting devices that is not expensive. What we have used, I guess, is around 200 euros. So it is not expensive. Flash, a tripod, an exposimeter, a color checker. As software for creating the digital map of the material, we have used Adobe Photoshop. This is how we have set up very simple studio. We have taken a box, we have made it darker. This is important for avoiding lighting sources that are different from the light to which you want to lighting the sample. We have set up the temperature, the power of the lighting system. These are very simple. In this case, we have a temperature of 5,600 Kelvin degrees. We have the lighting devices at 45 degrees. You see how the studio and how the camera is set up. We set on the bottom, we keep on the bottom of the box very simple. We take a sample of the fabrics. The fabric is the same that you have seen at the beginning. We stick on the bottom. We set up all the set using a PC. So every camera is equipped with its own software. You can use this software for making the shoots and regulating and set up all the parameters that you need. In this case, we have used the Digital Professional photo software of Canon. These are some information about the setup, file formats, sensitivity, the balance, color space, and so on. This is the image that we have acquired. So we started from the material, datasheet of the material, created the photo set for acquiring the pictures, acquired the pictures. Now start all the transformation of this picture into a digital version of the material. This is the transformation that we have made. And on the left, you see the digital version of the material. On the right, the material applied to a simple t-shirt. Going to speak about materials and the different typology of materials. As you see, we started from a natural material, and we arrived to have on this natural material or on this fabric, the digital version of the fabric. We can consider at least 3 different types of material, speaking in terms of digitalizing material: natural material, artificial material, native material. As natural material, we intended anything that is coming from the material from the nature without any type of processing, or where the processing of this material is reduced. All the material are mainly sourced by the nature. For what we call artificial material, like in the case of plastic, there is a processing that is transforming this material from its natural sources to the final sources, to the final form for the scope to which the material is intended. So, as I told you, natural materials are directly sourced from the nature. Artificial materials, on the other hand, they are going through processing to alter the nature of the material in a way that it can be used for the purpose that we have in mind. There are apart from the natural, apart from the artificial, apart from their version that can be acquired digitally, we have another type of materials that are the native digital material. It means that are materials that are not existing in reality, but that we can create inside a digital environment with digital processes, algorithms, softwares. So they are created, transformed, and applied only in the digital world. For the designer, one of the most costly and time-consuming tasks is for sure that of creating and distributing physical mock-up and samples of material. The digital tools are or can represent an help, a support on doing this, because it is possible to communicate the material and to go through the specification of the material across multiple locations and facilitate to collaborate also to creation of native digital material that can come from different designers. This is an example. So coming back to the digital acquisition of the image that we have seen. After the digital acquisition, we can unpack this digital version of the material in different typology of map. This map contains some digital information, different typology of digital information of the material. Here, in this case, you see the color map, the normal map, the roughness map, the displacement map, the alpha map. So from the scan device, I can generate a basic number of maps. So I scan the materials, I can generate a set of basic map of the materials. This set of basic map of the material, they can successfully modified and mixed to generate a huger set of maps that can be used also for generating new material or for changing the properties of the material from which we start. So the application of these maps in the layered scheme that we can see in this way are able to transform the material or to take the material from our real life and to replicate in the digital world, but it is also give you also the possibility to create, starting from this material, so to emulate existing material, so reproducing existing material, or to completely reinvent all the material in the digital world that you want to apply to your professional rendering. Now there is a video. As you see in the video, we start from we replicate the same type of lighting in which we have acquired the materials in the real world. We import the shape on which we want to render. We want to create the rendering of the material. The video is long, it's 20 minutes, so I will go to speed up a bit and showing you the most important part. After that, we have set up the exact condition of light that we have used in acquiring the image of the material. We are going to transfer, we are going to reconstruct the material using the maps that we have in which we have unpacked the material, we are going to reconstruct the same material in the digital world. So you will see now that we are going to work reconstructing the maps in which the material that we want to apply is unpacked. Okay, this now we are going to reconstruct the material. I want to speed up a bit.
Just to give an information, you are using not Claudio in this?
No, we are not using Claudio.
It is Max.
But for us, this is an important aspect. The philosophy on which these software are working are almost the same. Yeah. Speaking about 3D Studio Max, Claudio, Rhino, we have a plethora of software. Yes. The physical base is the rendering of a material. So we start, we digitalize the material, we create the maps, we create the texture, we apply to a render. Yep. And the basic procedure is the same. Yep. For all the software. So I suggest to all the students to not start to reasoning in terms of software, but in terms of procedures. Yep. Procedures, and understand what you are doing. It means which are the steps you need to have. You need to do for achieving your scope. If you are going to, with the experience, with the practice, at the end you are going to have this capability, you will see that there is no difficulties to go from one software to another. As you have seen, we have reconstructed the material and we have applied to the garment. Now the rendering, we start the calculation. It means that we start the rendering of the material on the shape on which we want to apply the material. Now we can go at the end. This is still calculating. At the end, the rendering is this. Okay, this is the first part. So this course, this is how is articulated the first course. That is mainly on digitalizing material, acquiring all the digital information, use this digital information in a way that you can arrive to on the shape. In this case is a t-shirt, but you can use also more simple shape or a garment more complex. You can arrive to apply the material to the digital garment you want to apply. The second, so going to the second course. The second course is going to, now we shift from the 2D dimension to the 3D dimension. 3D dimension, for us, it means mainly interface. We have worked a lot on the concept of garment as interface. This is one of the result of a project in which we also, Polytechnic of Milano was involved. That is Light Touch Matters, also TU Delft. I suggest you to maybe go and take a look to the results of these projects. There are some documents online that I suggest you, especially if you want to deal with fashion tech to study. This is an example of the product as interface that we design and prototype. So garment as interface, it means a lot of things. It can be sensorized, like in the prototype above, that is using piezoelectric sensor. It can be a protective, for example, a sort of protective interface, like the interface that you will see at the end of this video. So Carmentas interface has different possibility of product inside this term. But everything starts from the scanning, from the acquisition, from the biometric acquisition of a part of an entire human being. 3D scanning technology nowadays are becoming also extremely cheap. You can do with your smartphone. One suggestion that I have for you is not go to use extremely, when you are going to start to understand how is working a procedure, how is working a technology, my first, what I can tell you is to try to simplify your life. You have a lot of tools around you that you can use, a smartphone, for example, as a way for a biometric acquisition. As you have seen before, we have used a simple camera, and we have created in-house a very simple darker box for the digital acquisition of the image. This means that these are all procedure and technology that you can acquire and in which you can experience, that don't need to huge quantity of money or extremely complex tools to be used and to be learned. So everything starts from a 3D scanning, from a biometric acquisition. The biometric acquisition is it is imported into our digital environment. In this case, again, we have used 3D Studio Max. After that, we are going to think which is there. So we are going to generate the basic primitives, so a 3D shape that is representing as much as close as possible the interface that we want to generate at the end. We create a copy of this shape. We apply this copy on the part in which we want to generate the interface. So the copy is applied to the avatar. On using biometric polygonal modeling, that we will try to make some lectures also on that. You can modify the copy, so you can create different topology of geometry of the copy of the basic geometry that you have created, and modifying the copy of this geometry, you can create several types of shapes. These shapes are not yet applied to the final geometry. It means that you can simply generating all the number that you want of copy of the basic shapes, and you can apply geometric modification on this shape in a way to generate all the shape and all the type of shape that you want. Now you will see what we have made. For example, you can shorten this. You can take a bit more longer. You can apply a mesh. Like this. After that you have applied the mesh, you can go to work directly on the topology of mesh that you want. For example, you can create a mesh like this. You can apply an offset on the mesh. You can apply another mesh. Now let's go to see this video that is showing how we have proceeded. The video is showing the morphing relation between two geometries. It means that if you want to, starting from a basic primitive geometry, if you want to modify through morphing that geometry, as I told you, you need to create a copy of the original geometry that has, this is an important aspect, that need to have the same number of points of the original shape, and you can simply play on the copy of the geometry that you have generated, modifying the geometric characteristics. This is a cylinder, so it is not a complicated geometry. So you can apply different topology of transformation. And this transformation is applied directly by the morphing modifier. That is, you see now the geometry is modified. Based on the change that you want to apply through the modifier, you can generate different typology of geometry that you can go back to applying directly on your avatar. You have to think that if you, for example, you want to generate on the geometry that you have modified an organic mesh, for example, a bio-inspired mesh that can be also generated on the base of the modified geometry. When you are going, in the case of the polygonal modeling, when you are going to apply the meshes moving organically and with the geometry, the basic geometry in which you have applied the mesh. So these tools give you the biometric polygonal modeling and meshing, give you a huge possibility to work and play for generating geometries that can represent wearable interfaces. I guess this is finished. Okay. This is an example. This is an example of geometry that you can generate and print in a way that you have a wearable interface. Okay, this is the end of the lecture that we have prepared for you. So, summarizing what you will learn from our lectures, the lecture that we have prepared. First, the digitalizing material and using this material in professional rendering. This is the first course. The second course is that of using polygonal modeling and meshing to start to design wearable interfaces. Wearable interfaces that can be easily produced by additive production technology. And that's all from my side.